In this video, we're going to look at exponents. And the rule or the law that we are going to look at is the one that says if you have same bases and those bases are dividing, then you have to just subtract the exponents. Now, in the previous video, we did look at exponents and the base. In this video, I just want to remind you again, guys, that the number at the bottom is referred to as the base. So the number at the bottom, remember, we call that the base. And then the number floating at the top right corner, we're going to refer to that number as the exponent. So just make sure that you understand that we have that one as the exponent. Sometimes we can also call it a power. So a power. And the way you read this, you will say it is 2 to the power of 10 divided by 2 to the power of 4. Now, what does this rule say? It says that if those bases are the same, in this situation, we got 2 and we got a 2. Those bases are the same. And are those bases dividing? Yes, in this case, they are dividing. So to solve this or to work this out or to calculate this, all you have to do is subtract the exponents. So you take the 1 in front, which is a 10, and you subtract it by this one, which is a 4. So our answer over here, our answer now here becomes the base 2 to the power of 10 minus 4, which is 6. So we do this the same thing here. The bases are the same. They're dividing. All you have to do is say 7 minus 3. And the base is still going to be 3. So 7 minus 3 gives us 4. The exponent now changes to a 4. So that's how you simplify these exponents. So if I have 7 to the power of 9 divided by 7 to the power of 8, I will say this is now 7 to the power of 9 minus 8, which is 1. So I could say 7 to the power of 1. But remember, if the exponent is 1, you don't have to write it down. Just writing down 7 is okay. You don't have to say this is equals to 7 to the power of 1. You make that 1 invisible. So like that. In the next one, we have the bases. Over here, they are both x and they are dividing. So you just have to subtract the exponent. So this becomes x to the power of 15 minus 11 is going to give us 4. So that's x to the power of 4. Then over here, just be careful if there are now these negative signs in front of your sum, like this one and this one and that one. Remember to deal with those negatives first. So they are in front of your base. Ne? So you're going to be like, okay, what's the sign in front of this base? It's a negative. In front of this base is going to be a plus. So what's a minus divided by a plus? So a negative divided by a plus, we all know it's going to give us a negative. So the answer will be negative. And then you say this is 2 divided by 2. So those bases are the same and they're dividing. So I'm going to take this guy and that guy and subtract them. So the base is still 2. But then now the exponent will be 6 minus 5, which is 1. And remember, you don't want to indicate the 1 day. Now we got negative divided by a negative, which is going to give us a positive. And I don't have to show this positive here. So I'll just omit that. And then I go here. The exponent law says that if the bases are the same and they divide, all you have to do is subtract these exponents. So this is now 3 to the power of 2. Because 4 minus 2 is 2. And then over here, we got the bases are the same. They are both y. And they divide, so I'm going to subtract these two. So 5 minus 4, you know it's going to be 1. So this becomes y to the power of 1. But remember the signs as well, guys. So this sign here is a plus. Plus divided by a minus gives us a minus. So the answer is minus y to the power of 1. And you don't indicate that 1 over there. Over here, we got x divided by x. So all you have to do is subtract the exponents. So what is 12 minus 2? As we have learned here at the top, A minus minus times a minus is going to give us a positive. So this becomes 12 plus 2. So that's going to be 14. Because this whole thing here becomes a plus. And that's how you get 14. So this is now x to the power of 14. Let's continue over here. Over here, now we wrote the sums a bit different. It's still the same thing. We still have 2 to the power of 5 dividing 2 to the power of 2 over here, except instead of writing a division sign, we draw this line. So this reads 2 to the power of 5 divided by 2 to the power of 2. Because the bases are the same and they're dividing, I'm going to subtract the exponents. So this is 5 minus 2, which is 3. 2 to the power of 3 is our answer. And over here, I'll get 5 to the power of 2 because you're going to subtract the exponents. And then over here, what I want you to notice is that this number is the same as that number. Do you see that? And because they are dividing each other, they're going to cancel out and your answer will be 1 in this situation. The same way you had 2 over 2, it simplifies to 1 whole. 10 over 10, it simplifies to 1 whole. So that's what's happening here. If they look the same, they will cancel out. Now let's go to this one. Now we have a couple of more bases here. So what you need to remember still is that if the bases are the same, so the x's, they have the same base, and you can clearly see they are dividing. So I'm going to say 2 minus this invisible 1 that is over there. Then I'm going to get x to the power of positive 1. So the answer will be a 1 there, but I don't have to show it. Then times, now I need to deal with this, right? I'll say 5 minus 4, that's going to be y to the power of 1. So in simple terms, this is xy, because you don't have to indicate the times there as well. Now let's do this last one over here. We got 2 to the power of 5 divided by 2 to the power of 3. Same bases, they divide. I subtract the exponents. I'm going to get 2 to the power of 2, because 5 minus 3 is 2 to the power of 2. X to the power of 2, and then the y's, please notice again, the y's look exactly the same. This y looks like that's y, and they are dividing, so you cancel out those y's. So that's our final answer here. All right, that's it for this video, guys. I'll see you in the next one.